Find the point on the function f of x is equal to the square root of x that is closest to 4, 0. In other words, what we're going to try to do here is minimize distance between the function square root of x and the point 4, 0 by finding whatever point that there is on square root of x that is closest to 4, 0. So we're going to need a distance formula. And we know that distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's just in general the distance between 2 points. Now, we're not trying to find the distance necessarily to the curve itself. We're trying to find the distance to a point on the curve from 4, 0, and we're trying to find a point that minimizes that distance. So we definitely want to use this idea. So, what are our 2 points here? Well, one is obviously 4 and 0, and maybe I'll think of that one as being the point x1 and y1. But what about x2, y2? Well, we can call x x2, and then the y value, square root of x, is y2. So we can think of points on the curve as having the coordinates x comma square root of x. And that works. That's how we find those points. So if we substitute those values in, we're going to get d is equal to the square root of x minus 4 squared plus, we're going to have square root of x minus 0 squared. So that says d is equal to the square root of x squared minus 8x plus 16 plus x when we do that. Or d is equal to the square root of x squared minus 7x plus 16. So we want to take a derivative. We might want to think of this instead of being a square root as being something with a rational exponent. So we could rewrite this as x squared minus 7x plus 16 to the 1/2 power. So d prime is going to be 1/2 times x squared minus 7x plus 16 to the negative 1/2 times 2x minus 7. That's by the chain rule. And if we rewrite that a little bit, we'll get 2x minus 7 divided by 2 times x squared minus 7x plus 16 to the 1/2. That is, in the bottom we get 2d, twice the distance. Now, because this is a distance between a point on the graph and some other point that isn't on the graph, we know that there has to be an actual distance there. In other words, this distance is always going to be positive. So we're not going to get zeros in the bottom. In order to get a 0 in the bottom, that would imply that the point 4, 0 must be a point on the graph of the function. But we know when x is 4, y is 2. That's not true. So we only need to worry about the zeros of the top to find critical numbers. So we consider 0 is equal to 2x minus 7 and find x is equal to 7/2. Now we can create a sign chart with 7/2 on it, and we can test a little bit to each side. So we could consider f prime, let's say, of 3, and we could also consider f prime of 4. We've already said the bottom must be positive because these 2 points are not the same point. So if we plug 3 in, we'll get 6 minus 7, that's negative. We're decreasing on that side. If we plug 4 in, we'll get 8 minus 7, that's positive 1. We're increasing on this side. That definitely looks like a relative minimum. So the point on the graph that minimizes the distance to 4, 0 is going to be the point 7/2 comma the square root of 7/2. There you have it. Now, if you find the equation of the line passing through the point 7/2 and the square root of 7/2 and then the point 4, 0 and determine its slope, you will find that that slope is perpendicular to the slope of the tangent line at the point 7/2 square root of 7/2 on the function. That is, the distance from a point to a function will always go along a line that is perpendicular to the function, that is perpendicular to a tangent line at whatever point minimizes that distance. Not something you absolutely have to know or anything, but it's an interesting fact. And if you think about walking towards things, it should make a little bit of physical, that is real world sense.